All right. Continuing this conversation, and this is what's so wild about limits. They're super, super important to the foundation of upper level calculus. Without limits, you have no calculus. But the funny thing is, they're super, super simple. And a lot of times, if we get confused with limits, it's because we just assume that it's supposed to be really complicated and hard, and we want to make it hard. Just let it be easy. Just let it be easy. So the methods that we're going to eventually get into in the next several lessons is we're going to find limits graphically. Number two, using tables, and number three, doing it algebraically, which sometimes we call analytically. So here's our first live example, and you'll notice this function. It's a rational function, and you could recognize that by the way the function was defined right here. And it's basically linear, except there's this hole that we have right here at x equals 2. The function is undefined at x equals 2. And you'll notice by looking at the denominator that if x was allowed to be a 2, then you'd be dividing by 0, and hence the function's undefined. But what we want to do is introduce you to some limits here today. And the notation we use, we'll say the limit as x approaches 2 of f of x, okay? Now, this is what we call a general limit, or sometimes I'll call it a two-sided limit. And what we have to do before we can actually answer that question is we first have to do the one-sided limits. We're going to say, what's the limit as x approaches 2 from the left? So that little negative sign up there is to the left. And so what I'm going to do is I'm going to start just slightly to the left, and I'm going to walk myself a little closer, a little closer, a little closer. And as I'm walking and getting closer to the 2, the function's height is getting closer and closer to 3. So it doesn't matter whether this was open or closed. My answer is going to be 3 either way. And then I'll do the limit as x approaches 2 from the right. And now I'm going to start over here. Switch colors here, just to the right. And as I get closer and closer and closer to 2 from the right, again, we're approaching a height of 3. And then anytime these one-sided limits both exist and both equal the same number, we'd say the general limit exists and it equals 3. Now, if these numbers here were different from each other, then this answer would not exist, okay? Let's go look at another example in a table format that you'll see. And again, we're going to talk all about all these topics in much more detail. This is just a quick intro overview. So all of a sudden here, the interesting number is the 7. And you notice the function is undefined as 7. These x's right here, all of these values, this entire row are your inputs. And these are your outputs or your heights, okay? So we could say these numbers here sit just to the left of 7, right? So if we wanted to do the limit as x approaches 7 from the left, we'd look at these numbers. What do we get? What are these guys getting closer and closer to? They're getting closer and closer to 8. Now, if we want to do it from the right, okay, we're going to look at these numbers here that sit to the right of 7. And we could say the limit as x approaches 7 from the right is going to be what? This number is getting closer to this, getting closer to this. What are they getting closer to? They're all trending towards an 8. Now, that exact same table could be represented as a graph, and it would look like this bear right here. And you'll notice that the limit from both the left side and the right side are both approaching a height of 8. So you get the same answer whether you were reading that table just above me or this graph that we now have in front of us. Okay, the last thing I want to comment on is this, okay? A limit must approach, okay? This is great notebook material right here, some big key notebook material. A limit must approach the same value from both the left and the right in order for the two-sided or the general limit to exist, okay? So in this particular case, we've got two examples. Let's take a look at the one on the left here. Let's say I want to do the limit as x approaches 3, right? Okay, I'm approaching 3 from the left. I'm approaching 3 from the right. They both are approaching 5. Therefore, the general limit or the two-sided limit does exist. But over here in this case, if I want to do the limit as x approaches 3, the limit from the left approaches 4. The limit from the right approaches 6. Those are different. So we would say the limit as x approaches 3 does not exist. And that's the symbol we use.